Today I want to present FlowStrider, our tool that enables continuous threat modeling. I'm Bernd Kroner and I work at the German Aerospace Center in the working group for secure software engineering. Threat modeling is an approach to identify threats in software systems. Our tool focuses on threat modeling based on a data flow graph, which is an abstract representation of the software system. Threat modeling is an essential component of the secure software development lifecycle. Two recent studies showed that it is also an important topic in the open source community as well as in the industry. But there is a lack of resources like time, money, and security experts. And in agile processes, where we have to conduct threat modeling regularly, this problem gets even worse. That's why we need tool support to conduct threat modeling. And there are a lot of great tools out there. Another study showed that most of these tools focus on automation, but there are other important features for developers in order to use these threat modeling tools. And that's why we introduced FlowStrider. Despite automation, it introduced a practice-oriented workflow, has an integration for CI/CD pipelines, it's easy to extend, fully scriptable, and comes with two built-in thread catalogs. This enables an easy integration into the software development process. This is an overview of the workflow of FlowStrider. It consists of three main features: data flow modeling, knowledge and processing, and documentation and management. I will continue with the data flow modeling. FlowStrider takes as input the data flow graph and outputs an Excel file that contains all relevant missing information about the elements of the data flow graph. So we can fill in this missing information in the Excel file and update the data flow graph in order to make it more precise and improve the results of the threat modeling process. This is an example of a data flow graph defined in a JSON file format. Here is the visualization of our system. We have an application that communicates with a database and a configuration file and some third parties. Now we can extract missing properties of these elements. And all elements of the data flow graph are listed in this file, and all missing properties of these elements. For example, we can add store credential for the database here with true. And then we can update the data flow graph. And we see in the JSON file that our database has now the property stores credential. So we can refine our data flow graph. I will continue with the thread elicitation based on our thread catalogs. I will use our data flow graph as input for FlowStrider and elicit threads based on this graph. And now the report is generated for us as well as the management file. This also brings me to the next feature of FlowStrider, the documentation and management. In this step, a thread report is generated as well as a thread management file. This is the report generated by FlowStrider. It contains a visualization, an overview, and details about the identified threads. And there's also a thread management file that contains a list of all threads with its corresponding management state and an explanation. This management state says how the thread should be processed. For example, should it be accepted, mitigated, delegated, and so on. So it helps to document and manage each thread. This wraps up my short presentation about our continuous thread modeling tool FlowStrider. So check out our repository and have a look at our comprehensive documentation.